Hi, in this video I'm going to teach you how to write linear equations. So start with a little bit of review from Algebra 1. Slope-intercept form, and we have slope. Slope-intercept form is maybe the most famous of these. It's y equals mx plus b. Here m represents the slope, or the rate of change, and b would represent the y-intercept here. Okay? Now to calculate the slope, we do change in y divided by change in x. So on top of the y's, y2 minus y1, and on the bottom, x2 minus x1. It doesn't really matter which point you choose as first and which one you choose as second, but once you make the choice, make sure you're consistent. So that if you choose the second point to subtract the y's on first, make sure you also choose the second x to use first. Okay. Now both of these forms are helpful, and you've used them a lot. We're going to introduce a third formula that makes some problems a little bit easier here. Right, it's called point-slope form. The reason we call it point-slope form is it's a formula so you only need the slope and a point to be able to write a linear equation. Now, if you actually compare the slope and point-slope forms, you'll see that these equations look very, very similar. And actually, if you just multiply the slope formula by x2 minus x1 on both sides, that's basically where we get this from. So this is a special form of the slope formula that we can use to write linear equations. All right, let's do a couple of examples. Example 1, we're given a slope of 3, and we want this line to contain the point 1 comma negative 1. So we're given slope, we're given a point, we're going to go ahead and apply point-slope form. Then go ahead and I label x1 and y1. Just say, okay, these are my particular values of x that I want to make sure work. Now using this form, y minus negative 1 equals 3 times x minus 1. Right? At this point, all I've done is taken this formula and plugged in my slope for right there, and then my x1 subtracted from x, and y1, negative 1, subtract that from y. Right, now let's clean this up. Minus and negative 1 is going to be plus 1. And then I'm going to distribute that 3. And so I get 3x minus 3. Now, this is a perfectly fine linear equation, but for most of ours, we're going to want to end up putting them into slope-intercept form. The main reason for that is that when we put it in this form, the parameters, slope and the y-intercept, have a lot of meaning for us in many problems. The slope is going to be the rate of change, and then the b is kind of like the starting point. Okay? To get this into this form, all I have to do is get rid of the plus 1. Subtract 1 from both sides. And I get y is equal to 3x minus 4. So this would have a slope of 3, a y-intercept of negative 4, and with linear equations, it's always pretty simple to check, did this match what we started with? Well, the slope is 3, so that works out. I want to check this last point. If I plug in 1 for x, I get 3 times 1. 3 times 1 is 3. Subtract 4, I get negative 1, which is exactly what it should have been. Check. Right. Now the second problem, the second example here, I'm not given the slope, I'm just given 2 points. But if you think back to geometry, we know that 2 points determine a line. So from these 2 points, we should be able to figure out the slope and then figure out the equation of a line that would fit these points. So to start off with the slope, right, I'm going to use my formula over here, change in y divided by change in x. See, for my points, I'm going to label these two. So say x1, y1. Right. For me, that makes it a lot easier so that I don't make any silly mistakes. So let's start off y2 minus y1. And on the bottom, x2 minus x1. All right. Now I have to be really careful with my negatives. 6 minus 1 on the top is going to be 5. On the bottom, if I have negative 2 minus 8, that'll give me a negative 10. All right, simplify negative 5 over 10, and that is just negative 1/2. Right. So my slope in this example is negative 1/2. I just put that work on the side, because now I'm going to use this, and it's going to look a lot like the work from up here. So now with using point slope form, I have the slope, and I actually have two different points. So the question comes up, which one should I use? Turns out it doesn't actually matter which one you use. You'll end up getting the same simplified answer at the end. Since you'll get the same simplified answer at the end, I'd recommend choosing the one that looks like it might be easier. In this case, I'm going to choose the point 8, 1 because it doesn't have that negative, and that negative sometimes introduces a chance for a little mistake, sometimes forgetting it, or there's little things there. So I'm going to use that guy. It doesn't really matter, but I'll choose that one. So y minus y1, the slope, which is negative 1/2, times x minus 8. Right. So I've got the first version of my linear equation. Now I just want to simplify this and put it in slope-intercept form. So I have to distribute that negative 1/2. Negative 1/2 x plus 4. Okay. Now to get rid of the minus 1, I'm going to have to add 1 to both sides. And I end up with the solution y equals negative 1/2 x plus 5. Just as we did on top, I want to double check my work. I have 2 points, and if this is the correct equation, I should be able to substitute this x in and get this y out. And the exact same thing with negative 2 and 6. All right, quick check. If I plug in 8, negative 1/2 times 8 is negative 4. Negative 4 plus 5 is positive 1. So that point checks out. If I plug in negative 2, negative 1/2 times negative 2 is positive 1. Positive 1 plus 5 is 6, so they both check out. These two examples don't cover every possible situation where you might want to write a linear equation, but the ideas are going to be the same. You need to know at least one point, and you need the slope, or you need to be able to find the slope. One example I did not go through here would be if you're given a table of points. But if you think about like what a table of points means, it's really just a bunch of points that are organized in a different manner. So in that case, you can pick 2 of them, find the slope, and then write the equation the same way. So to review a little bit here, we have slope-intercept form. We like slope-intercept form because if you're given the slope and the y-intercept, it makes it really easy to write. And also, the m and the b have really nice interpretations in most real-world problems. Right? To do these, often you'll need to be able to calculate the slope. Slope is just change in y divided by change in x. And the new part of this video was point slope form. Point slope form is nice because if you have a slope and you have just a single point, it's pretty simple to write the linear equation.